Hello everyone, welcome back to my channel. In today's tutorial, we are going to talk about the world of networking. We'll start with fundamentals concepts, basics, the type of networks, and the components of networks, and also the topologies and utilities needed for everyday life of a DevOps engineer. So let's go ahead and start our tutorial. So what is network? A network is a collection of devices such as computers, printers, and servers connected together to share resources and information. You can think of a network like a city road system. The devices are like buildings and the connections between them are like roads. Just as car travels on roads to reach different destinations, the data travels through connections to reach different devices. Okay, so what type of networks we have? So we have LAN, MAN, WAN, and SONET. So LAN is a network that connects device within a small geographical area like our home or office. Think of it as a road within a small town connecting all the local buildings. And then the next one would be MAN. MAN is nothing but a metropolitan area network. It's a city-wide network that connects various government buildings or say educational institutions. And the next one would be WAN. So WAN on the other hand connects network across larger geographical areas like cities or countries. So it's like a highways connecting different towns and cities. And the last one would be SONET, which is also called as synchronous optical network. It's kind of undersea fiber optic cables that connects continents. So let's go to the next topic, the network components. So the network components we have switch, router, modem, hub, NIC, bridge, right? So let's go ahead with switch. Let's think of a switch is a device in a school computer lab that connects all the computers to the local network. And the router. Next one is a router. The device that connects your home network to the internet, allowing multiple devices to access the web. So if you come down here, I have shared this design for you. I think if you see here the switch, when I talk about switch, this is a switch which connects all the devices, and the router is something which connects your home network to the internet. It's basically this router is the main responsible for connecting your home network to the internet, allowing multiple devices to access the web, you know. Okay, and the next one would be modem. Modem is actually this is a which is called as ADSL modem, provided by internet service provider, which will be provided by them, that translates digital signals from your computer to analog signals for transmission over telephone lines. And the next one would be hub. A hub is a older technology used to connect computers in small office, but it's without the ability to intelligently direct traffic. So I think hub is the old one, so we don't need to worry about it. And the NIC is also old one. Actually, it's called a network interface card, the hardware inside your computer that allows it to connect to your Wi-Fi. It's basically. And the other one would be the last one would be the bridge. A bridge is a device that connects two different LANs in a university campus, making them function as a single network. Yep. So it's like multiple LANs can be function as a single network using bridge. Okay. And the next one, okay. So then the next part would be networking models. So we have two type of models: OS reference model and TCP/IP model. I think the theoretical OCP reference model is a theoretical model which we use in textbooks to explain how different networking protocols interact. And TCP/IP model is more of like describing how the internet works, including protocols like HTTP, FTP, TCP, and IP. So if we go in depth into this OS model and TCP model, so this is what we have in here. I'll just give a brief explanation. The summary would be, in summary, like while both models help in understanding network interactions and designing network systems, the OSI model is more abstract and comprehensive, whereas the TCP/IP model is more programmatic and closely tied in the real world implementation of the internet. If you want to know more about this, I'm going to share details about these things, but I'm not going to cover more on this. Let's go ahead. So the next one would be the network topologies, and let's go ahead and talk about them. So we have multiple topologies like bus topology, ring topology, star topology, tree topology, and mesh topology. So let's go everything one by one. Okay, the topologies. The bus topology is like a single communication line, and the ring topology is like a circular network structure. And the star topology would be a central hub with point-to-point connections. And we have tree topology, which is a combination of bus and star topology, and the mesh topology is the main one. So this is where this is the good topology which we use to interconnect through redundant connections actually. So yep. And yeah, I think we covered most of the part. Let's go to the utilities and others. Like these are the network utilities we use every day and day to day as a DevOps engineer, or maybe for any software engineer, you should know about this. So the first one is protocol. The protocol is a rule that defines how your web browser communicates with web servers like HTTP or HTTPS. So whenever you try to hit a URL, if you see here, when you try to hit a URL, it should always show as secure. So this is when you see this as secure, this is called HTTPS, and if you don't see it as secure, which is called HTTP. So protocol is something which is refers to that. And the next one would be IP address. Every IP address will have a unique value or unique address that assigned to your computer by your ISP. It's like a postal address for your online activities. I'm going to cover more on IP address in a few minutes, but let's actually explain more about IP address. I have gone through some of the details. So before talking about IP address, we want to understand how these things work. So let me take you address. We need to have a good understanding about how the decimal and binary works, and this is because computer will only able to understand binary form and the decimal. So the decimal, here is the example I just gave you. So this is the decimal where we are using 128 as for example. Every decimal will have a 10 to the power of series, and every binary will have 2 to the power of series. And decimal, for this decimal we have 10 to the power of 0, 1, 2, and which if we count it, it will go to 128. And if you're trying to convert this to binary, so every binary will have 8 bits, which are also called as one octet, right, or one byte. So we'll just remember it as one octet. Octet is something, if you see here, this is the octet. So it's basically 8-bit would be one octet. You just remember that, which is very useful. And if you don't know anything about it, I'll just share the links of the details, what are the details about octet and how it works. But for now, you just need to remember we have 8 bits. Like these are, we have maximum in 8 bits for every binary form, like which will start from 2 to the power of 0 to 2 to the power of 7. And there are maximum combinations would be 255. So actually the maximum combinations would be 256, which would be from 0 to 255, right? So for 256 combinations we can have for binary, from starting from 2 to the 0 to 2 to the 7, which would be from 0 to 255. So from 0 to 255. And this is why, because we need to understand about this, because all the IP address will deal with the binary form, right? So let's talk about what is IP address. So an internet protocol address, is numerical label assigned to devices connected to a computer network that uses IP for communication. So the IP address acts as an identifier for specific machine on a particular network. So it also helps you to develop virtual connection between destination and source, and is also called IP number or internet address. It helps you to specify the technical format of addressing and packet scheme. Most network combines TCP with IP. The IP address consists of 4 numbers. Each number, let's take an example of this IP address. So each IP address will have 4 octets. So if you remember, I just explained about 8 bits would be 1 octet, right? So right now all the IP4 address will have 4 octets, that would be 32 bit. So that would be 8 into 4, like 8 into 4, right? 8 bits into 4 would be 32 bits. So 32, right? So, and usually the first two in IP address, there are two things we need to understand. So this is divided into two parts. So that's the first part, and this is the second part. The first part would be prefix. The prefix part of the IP address identifies the physical network to which the computer network is attached. So you can think of like a prefix is also known as network address. So this is the network address. And suffix part identifies the individual computer on the network. Like the suffix part is called host. So this is network and this is host. Just remember this. So that's how the IP address has been divided. In networking terminology, if you see there are multiple in IP address. If you see there are classes. So you need to understand about these classes before understanding about IP address. So these are the classes. You remember I just explained about 255. The highest combination would be 255 because there are 256 combinations, which would be the highest number would be 255. So any IP address, if you whenever you get any IP address from someone, the highest number would be 255. That would be 255 dot 255 dot 255 and dot 255. So this is the highest number anyone can think. So the first part would be network, as I explained. So this is the IP address. Anyone can. This is the highest number of IP address. It can't go beyond this. So just remind that. And now, since we have three type of classes, right? Let's talk about the first class. So how does the IP address work? The IP address works in a IP network like a postal address. For example, a postal address combines two address or your area or your house address, right? So the address or your area is a group address of all houses that belongs to a specific area. The house address is the unique address of your homes in that area. Uh, Here your area is represented by pin code number. In this example, the network address comprises all the hosts which belongs to specific network. So like actually this is called as a classful networking. So what is classful networking? This class is nothing but a classful networking. The classful addressing, actually it's called as a classful addressing. Classful addressing is a network addressing the internet architecture from 1981 till classless interdomain routing was introduced in 1993 actually. So this addressing methods divides the IP address into 5 separate classes based on 4 address bits. So if you see, this is the 4 address bits, right? So here class A, B offers addresses for networks of 3 distinct network sizes. Class D is only used for multicast, and class E is reserved for experimental purpose. So you don't need to worry about the D and D. We'll just consider it on E, A, B, and so. So let's talk about class A. Let's talk about class A. The class A, the range would start from, if you see, 1 to 126. This is nothing but the first part. If you remember, I just explained the first two parts would be network, right? In here, the range, for the first range, it will start from 1 dot 0 dot 0 dot 1 to the last number would be 126, right? So the 126 dot, the next number would be 255, and the next number would be 255, and the next number would be 254. So this would be the range of class A. Sorry for the handwriting, I think I'm new to this, but I try to Okay, and because we use this class, this is the range of the class A, and the networks would be few but large in size. These are already occupied or reserved by big companies, and you will not get this kind of IP address whenever you buy any server or you get anything. So these are all like reserved, and these are like this would be very less. But see, if you see, the number of networks are available is 126, but the maximum nodes in a network would be like 16. I think it's around 4 million actually. Okay, and if you see in the next one, and actually the structure, the structure of class A, the first 8 bits for the network. If you see, this is the first 8 bits would be network, and all the rest would be host. So that's how it is for the class A. So let's talk about class B now. So the class B range will start from 128. So you can ask why it will start for 128 but not 127. If you remember, your local host will always listen on 127.0.0.1. So the local host will be reserved, so that's why we'll not have this included. So that's why we are going with start 128.1.0.1. It will start from this range, and and the final range would be 191, right? And the final range would be 191. So we'll start from 191 dot 250 while will go on, and the next one would be the same. I think 255 and 254. It would be same because these are like, so 255 and 254, vice versa. And this is B class. These are more than networks more than class A. When we compare from class A, these are like more networks. If you see, 16,384, but medium in size. The size is very less when compared from class A. Example, in the first one would be large corporations, as I explained, like governments and corporations. And here, the example for class B, you can think of universities and mid-sized companies. And here, the first 16 bit of net will be allocated for network. The rest would be host, right? You understood? So the first 16 bit, the first 16 octet, like or 2 octets, the first 2 octets would be uh, dedicated with for network, and the rest 2 would be host in this. So let's talk about C class now. So the C class starts with 192, right? So it would be the same. So 192.0.1.1, and the ending, I think the ending would be, I think it's 224, right? I think it will be 223. Yeah, if you see here, the ending would be 223. So the IP address will start with 223, and the rest will be the same thing here. 55, 55.54. Okay, I think it's similar. Same thing actually. And and when I explain, if you see all the networks, there are many networks, many but very small in size. In this, the first 24 bits would be dedicated for network, and the last 8 bits would be for host. 8 bit for host. And for the example, we will be using small business personal networks for this class C actually. Okay, that's how it works. So let's talk about the other parts. We just covered about IP address. So let's talk about DNS. So Before talking about DNS, I think I will explain how the application layer works in both ISI and TCP/IP model. So I think I only explained about the summary, but in detail. So if you see here, this is the OSI model reference. Is a reference model. Actually, it's created by International Organization for Standardization, which describes how different type of systems communicate each other. The OSI model consists of several different layers, as you see: application, presentation, session, transport, network, data link, and physical, right? So the application is nothing but a human computer interaction layer, where applications can access the network services. And the presentation layer would be which ensures the data is in usable format, and it's and is where data encryption occurs actually. And then maintains connections and is the session layer is something which maintains connections and is responsible for controlling ports and sessions. And the next one would be transport layer. Transport layer is something which transmits data using transmission protocols called TCP and UDP. And the network layer, you also know, decides which physical path the data will take actually. And the data link like defines the format of data on the network. And finally the physical, it will transmits raw bit stream over the physical medium. So if I go to the application layer, here where the HTTP will be, and like which is HTTP is nothing but hypertext transform protocol. uh, it's actually client server stateless protocol, and it tells how it request any data from the server, and also tell us how the server will send back to client actually. This is where the client and when client makes a request, HTTP is response, the server sends response to client HTTP to client actually in a HTTP response. So we have like minimum status codes. And the presentation layer is something when you see a web page like Google or youtube.com, right, there you can see many videos, images, thumbnails of videos, comments and all. So presentation layer helps to represent the data of any format. And the session layer is moving to session layer is actually create and maintain the sessions within the time frame. Whenever you open a bank website, it has a time limit, if you remember. If you are away from your keyboard for some time, then the session will automatically go out. If you are not using any keyboard or mouse pointer, mouse or anything, then the session will log out automatically by session layer algorithm written by developers. This is responsible for session layer. And the transport layer, this means the layer divides the data in multiple chunks or parts. Like basically the layer, this layer, the data is converted into small segments, which means the layer divides the data in multiple chunks or parts. This layer is responsible for sequencing the segment, means it was actually adding the serial number on each data segment. Because when the data is traveling from one PC to another over the internet, so there is a chance that one part segment of data will be dropped. So in that case, when the data will reach from, let's say, from host A to host B, then B will check, okay, right, I got like some 1 3 2 4 5 segments, but I don't receive this particular 6 segment. So then B will send request to A again, asking, can you please transmit again for segment 6. And then this layer use some checksum, and it takes care of and it take care of conjunction control, and this layer is responsible retransmission. So that's what we use for transport layer. So it's kind of validates thing, and it re-requests for any retransmission again. And in this transport layer, we'll have TCP. TCP is nothing but transmission control protocol. In this protocol, if any segments of data is transmitted from host A to host B, I'll use the same example. The destination host B will send back a receipt or acknowledgement to sender host A. Means whenever we send a data with TCP, it actually takes care of acknowledgement. So this protocol is reliable, and also it retransmits the data segment if any segment is dropped. So in network language, this protocol is connected oriented because actually it's connection oriented because it believes in making connection end to end. It takes 20 bits to add TCP information on each segment. This information contains port numbers. Port number in which application you want to send your data is recognized by port numbers actually. Like for example, HTTP port 80. For MongoDB we use 27017, and SQL we use 1433, etc. So that's about it. And we have UDP as well in this layer, in the transport layer, We have TCP and UDP, both are present in this layer. UDP is nothing but user datagram protocol. This is like connectionless, meaning it doesn't make any connection with the receive to check whether all the data segments are reached successfully to the receiver or not. So it is not reliable since it doesn't care of any acknowledgement. So retransmission is not possible with this protocol. It takes 8 bytes to add UDP information on each segment. These 8 bytes contain port number, same like TCP. So we talked about the transport layer. Let's talk about the network layer. In this layer, each data segment is converted into packets. So in each packet, source IP and destination IP is added by this layer. Actually, packets is the abstraction of segments. You can think a router works in this layer for connecting one host to another host, like different network. And the data link layer. In this layer, each packet is converted into a frame. You can think in each pocket, in each packet, sorry, in each packet, the source MAC address and destination MAC address, physical address of the device is added to this by this layer. Frame is another abstraction layer of packets which contains both the MAC address. So switch works in this layer for selecting which device it has to send the data connected with that switch. Finally, I think the physical layer. Physical layer, in this layer, the data will be transmitted into digital signal 0 and 1 is called. Okay, we are talking about TCP IP model now. This model is real model which actually works in real world. This model consists of 4 layers: application, transport, internet, and link or network interface. So the application layer in here, when we compare with OSI model, this application presentation or session are combined into a one application layer, and transport will be same, and the network will be having like will be the same as internet actually, and then the data link and physical link will be combined into link or network interface. So now we talked about these models, so let's talk about DNS. Okay, let's talk about DNS. DNS is a domain name system. DNS translates the human readable domain names, for example google.com, to machine readable IP address. For example, we'll have a IP address similar to so this is IP4 address, right? Yep. So this is IP4 address. So the example, like whenever we try to hit google.com from the any device, the DNS will internally connect to IP address. It will resolve for any IP address and internally connect to the IP address which is connected to this domain. Basically, that's how it works. And you can think it as a phone book for any other. It's like a phone book of the internet. Each device is connected to the internet. You will have a unique IP address, as I explained before, which other machines use to connect or find the device. DNS servers eliminate the need for humans to memorize IP address which are in IP4 format, or more complex new alphanumeric IPv6 address such as in IPv6. So I think I forgot about one more thing, IPv6. So this is a 32-bit or like 4 octets, which is 32-bit, right, for IPv4 6. But if you talk about IP6, so IP6 is more into actually. It's a vast weight of a network, like when is also based on IPv4 and stands for Internet Protocol version 6. It was first introduced in December 1995 by Internet Engineering Task Force. IP version 6 is a new version of Internet Protocol which is way better than IP version 4 in terms of complexity and efficiency. IPv6 is written as group of 8 hexadecimal numbers. If you see here, these are 8 hexadecimal numbers actually. It's separated by colon. It can be written as 128-bit of zeros and ones. So initially when you saw this is only like 32-bit, right? Here it is 128-bit. So which is written in group of 8 hexadecimal numbers, as I explained. The benefits of IP6 are its large address space. Will have greater address space than IPv4, which is required for expanding the IP connected devices. So, and it's improved security, has more improved security which is built in with it. It offers security like data authentication and encryption, and also it has simplified header format actually. When compared to IPv4, it has simpler and more effective header structure. This is more cost effective and also increase the speed of internet connection. And also it has improved support for mobile devices. The main difference was IPv4 is increased and better support for mobile devices. It's help in making quick connections over there, over other mobile devices or in other safe way than IPv6. The key difference between IPv4 and IPv6 is, as I explained, IPv4 is 32-bit. This is 128-bit IPv6, and IPv4 it supports manual and DHCP address configuration, uh, and it's only the IPv6 is only supports auto and renumbering address configuration. So IPv4 end-to-end connection integrity is unachievable actually. In IPv6, end-to-end connecting integrity is achievable. So that's a simplified details of IPv6. So okay, so now let's talk about subnet mask. So we already discussed subnet. This is the usual subnet would be for any environment, like this will be normal. So what is subnetting? Subnetting um, is a goal of the goal of subnetting is to create fast, efficient, and resilient computer network. As networks became larger and more complex, the traffic traveling through them needs more efficient routes. If all network traffic were traveling across the system at the same time using the same route, bottlenecks and congestion would occur, resulting in sluggish and inefficient backlogs. Creating a subnet allows you to limit the number of routers that network traffic must pass through. An engineer can create smaller mini routes within a large network to allow traffic to travel the short distance possible. So how does subnetting work? So I got a diagram for this. So let's talk about a class C network without subnetting and class C network with two subnets. So in here, if you see, this is the IP address for the starting host IP address and the ending start. This will be huge network, right? If you go here, it was starting from here to 254, right? The host. So actually, this is more complex. As I explained before, all traffic across, if the traffic network traffic was traveling across the system at the same point, but you only need to have a small number of versions or small number of things. IP address allows help to identify the piece of hardware connected to a network. So to locate a particular device, you will need the organize the IP address into a logical way. That is where subnetting excels a tool to help you maintain efficient across your network. There could be hundreds and thousands of devices that are connected to within the same network, and the corresponding IP address can create a complex route that creates much travel. So subnetting limits the IP address usage to within its few devices. If you see here, we divided the big network to two subnets. So it will start from 14.0 to 14.126 here, and then 127 is used for localhost, and we start for 128 again. So these are two kind of subnets. This allows an engineer to use subnetting to create subnetworks, sorting data that it can travel without touching every part of the complex routers. To do this, an engineer needs to match each IP address class to each subnet mask. The subnet mask equals an IP address, but it can only be utilized within the internal network, like in this network, right? This marks helps to identify which part of IP address relates to network and which part relates to host. So specific data is sent on particular routes according to the destination. Subnet mask creates the tool that enables a router to match an IP address within a subnetwork. Basically, it's in a subnetwork. Benefits of subnetting. The subnetting divides broadcast domains so traffic is routed efficiently, improves speed and network performance. A subnet mask ensures the traffic remains within the designated subnet, and the network security can be boosted because of this. Some organization is crucial within large business. Subnetting allows companies to have full control over the traffic, data packets, network, and all routers. So why we use networks? It will enhance network security, efficiency, and performance, and creates a speedier set of route maps for data. Yep, I think that's all about the ping. Is the next one would be the ping. Yeah, the ping is nothing but when you try to uh, let's open any pinging any IP address or something like that. Let me go back. If you want to do ping google.com, www.google.com, it will just try to ping the host name and it will show the response whether we are able to connect or not. So that's how it works. Yeah, I think I covered most of the part I was discussing about. So I hope you guys liked my video. Please do like and subscribe my video if you do like my content, so that I will do get to do more videos like this. Please do encourage me, and please subscribe to my videos. That's all for today's video. Thanks for watching. See you on the next video.